Okay, so suppose the velocity of a particle is given by 5t squared minus 125t, and that particle is moving on the x-axis. At t equals 0, the particle is at 4, 0. So the first thing to note is that this is time, and our velocity is given with respect to time, but this is an actual point, so this is an xy point. So our x value is 4, our y value is 0. So there are all kinds of questions you could get asked about this. So one question they might ask you is to determine the position of the particle at any given time. So I'm going to find the x position with respect to time. So to do that, I'm going to be going from velocity to position, which is the antiderivative. So I'm going to carry my 5 down, raise the power of my t by 1, I'm doing the power rule, and divide by my new exponent of 3. Minus, keep the 125, the t to the first changes to a t squared, divide by 2, plus c. So then this is just the general solution for my position function, but I want the position function that at time 0, initially, it's at 4, 0. So my x value is 4, so I'll put my 4 right here, equals, and then I would plug in 0 for my t. Well, that means I'm going to have 0 minus 0 plus c, so c equals 4. So my position function is x of t equals 5t cubed over 3 minus 125t squared over 2 plus 4. So if I wanted to know where was the particle at time 2, I could plug in a 2 for my t and that would give it to me. At time 3, plug it in. So this is the general position function at any time, and it includes our initial position of 4. If I was asked about which direction the particle was going, so was the particle moving to the left or right at any given time, I would know that from the velocity. When the velocity is positive, the particle is moving to the right. When it's negative, it's moving to the left. So what I'm going to do to actually figure that out is set my velocity equal to 0. So 5t squared minus 125t equals 0. And I'm going to find these t values. So I'll factor out a 5t. I'm left with t minus 25 equals 0. So t equals 0 or 25. And for this problem, I would just say that it's initially at time 0. It's at 4 zeros, so I would start at 0, but 0 is going to be an important number anyway. But the point is I'm not going to go back into negative time. So I'm going to draw a number line for my velocity, and we're going to look at the signs of the velocity. So important numbers are, of course, 0 and 25. So I'll pick a value between 0 and 25, and I'm going to test the sign of velocity. So I come over here to the velocity equation, and I'm going to use the factored form. So if I pick 10, 5 times 10 is a positive, 10 minus 25 is negative. So a positive times a negative is negative, and I know that that means the particle is traveling to the left. If I pick a number in this interval from 25 to infinity and plug it in, I'll have the other side. So if I pick 50, 5 times 50 is positive, 50 minus 25 is positive, a positive times a positive is positive, so my particle is traveling to the right. Now a number line does not give a justification. So if I was asked when was the particle traveling to the left, I would say on the interval from 0 to 25. And those are times from time 0 to 25. And I know that because my velocity with respect to time is less than 0. It's moving to the right from 25 to infinity, and I know that because my velocity was greater than 0. So these are some things you can tell from velocity. Of course, a velocity less than 0 means the position is decreasing. And of course, position decreasing in this case means moving to the left. For a velocity greater than 0, the position is increasing. What about the acceleration? What does acceleration give you? Well, one thing that you could get asked about acceleration is the particle speeding up or slowing down at any certain time, or when is it speeding up, when is it slowing down, etc. So acceleration is the combination of velocity, speeding up is the combination of velocity and acceleration. So I'm going to find A of t. And to get A of t, the acceleration is the derivative of velocity. So I will use the power rule. I'll multiply down 10t to the first, or just 10t, minus 125t to the 0, or just 125. So I will set this equal to 0. So 125 equals 10t, and t equals 12.5. So a number line for acceleration would look like this, and we're still starting at 0 because we're not dealing with negative time, and I would put 12.5 on it. If I pick a number from 0 to 12.5 and actually plug it into my acceleration, like let's say 1, 10 times 1 is 10, minus 125 is a negative, I know that my particle is being pushed to the left. If I pick a number to the right, let's say 50, 10 times 50 minus 125 is definitely positive. It's being pushed to the right. This is my acceleration. Now, one way to do speeding up or slowing down would be to know only about velocity. It would be, okay, I know that my velocity is negative. If I knew if it was increasing or decreasing, I would actually know. Negative and decreasing would be speeding up. Negative and increasing would be actually slowing down. With a positive velocity, if the velocity is increasing, positive and increasing, then it would be speeding up. Positive and decreasing, it's slowing down. Well, this negative here in acceleration from 0 to 12.5 tells me that my velocity is decreasing from 0 to 12.5. From 12.5 to infinity, my velocity is increasing because my acceleration is positive. So what you can do is actually just make a combined number line, and I'm going to put velocity on the top and acceleration on the bottom. And I'm going to put all my important numbers. So 0, 12.5, and 25. The 25 from the velocity, the 12.5 from acceleration. For my velocity, I know my velocity is negative from 0 to 25 and then positive after. So I'm going to put a negative up until I get to 25 and a positive after. Acceleration is negative before 12.5 and positive after. Well, now I can compare the signs. Velocity and acceleration have the same sign from 0 to 12.5 and from 25 to infinity. So since they have the same sign, they are working together and my particle will be speeding up. And the literal justification would be V of t and A of t have the same signs. From 12.5 to 25, the signs are opposite. So I know from 12.5 to 25, the particle is slowing down. And the justification would be V of t and A of t have opposite signs.